Okay, we are going to do 7.5, ready, set, go, number 14. And that relates to 15 as well as, not 16, but 14 and 15. So we will do 14, and then because you know how to do 14, you'll be able to do 15. It says, let sine of theta equals to 3/4. Use the Pythagorean identity, sine squared plus cosine squared equals 1, to find the value of cosine given pi over 2. Theta is between pi over 2 and pi. So the very first thing that you need to do is you need to draw a picture. So the picture that I draw, and again, you could be using I'll show you how to use the unit circle as well, but I like this way better because I don't have to keep referencing the unit circle, and then it gives me reference of this. And actually, I lied. You cannot use the unit circle for this one. So this is yet another advantage of why this way is better, because it works for all angles and not just your 30, 60, 90 and your 45, 45, 90. Okay. So it says let sine be 3/4. So you always draw a picture and it's like this, right? And then you label things. And because sine's definition is opposite over hypotenuse, right? Then I label the opposite 3 and I label the hypotenuse 4. Okay. And then it says use the Pythagorean theorem to find the value of cosine given that theta is between pi over 2 and pi. So number one, you notice, oh, Ms. Johnson, you've drawn it in the wrong space. Yes, but I purposefully do this to let you know that there's more than one answer, and you have to be diligent in finding that you are finding the right answer that they're asking for. So clearly I'm not in the correct quadrant. So some of you are like, oh, that's not a big deal, Ms. Johnson, just reflect it across the y-axis and then you're good. Some of you are thinking, what are you talking about? So they're asking for the same triangle. So this is the same triangle being drawn. It should look like a reflection, but of course, Ms. Johnson has challenges drawing. So now your theta is here, right? So you're still going to use the fact that the opposite is 3 and the hypotenuse is 4, right? That's still true. So now they just want to know what the cosine is. Okay, so when you're doing this part, you know that cosine, his definition is ka, which is adjacent over hypotenuse. And you're like, wait a second, what's the adjacent? You didn't give me the adjacent. That's your job, right? So whenever you're dealing with right triangles, you think about these 3 tools. And I think I've said this a bunch. So here's your right triangle tools. It's your Pythagorean theorem and then trig. Well, Pythagorean theorem actually is going to help you out in this time because you have 2 sides and you're trying to find that third side. So I'm going to use the Pythagorean theorem in order to find my cosine adjacent side, right? So I'm going to write this down. So this says, let's see, cosine. So it's going to be 3 squared plus what squared gives me 4 squared. You can label this as x if you want. So this is 9, this is 16. So that's x squared is equal to 7, right? So therefore, the square root of x, don't forget your plus or minus, because this is actually going to come into play right now, right? So x could be positive root 7 or negative root 7. So I'm going to write that out as positive or negative root 7. Now, obviously, over here, you have your positive root 7. And obviously, over here, you have your negative root 7. This is why you don't forget your plus or minus. So now that you have negative root 7, now you can find your cosine. And your cosine is just negative root 7 over that 4, your hypotenuse. And so then you're done. So your directions for this are going to be draw the triangle, label your triangle, check your signs, right? So make sure you check your signs, because even if I was to use this original triangle here, I would have gotten the same answer, because then I would have checked my signs and said, okay, in the second quadrant, in this quadrant here, is cosine supposed to be positive or negative? And the list that's running through my head is, well, in this quadrant, in the second quadrant, because x goes left, my adjacent side goes left, that's negative. So therefore my cosine has to be negative. The other little mnemonic that I helped you guys use before was all students take calculus, which basically means that in this quadrant, all of them are positive: sine, cosine, tangent. In this quadrant, only sine is positive. In this quadrant, tangent is positive only. That implies that cosine and sine are negative, which makes sense if you think about why it would be negative in the third quadrant. Because look, in this quadrant, x goes left and y goes down, which both mean negative. And then you'd say, okay, well, Miss Johnson, why is tangent positive? Because tangent is sine over cosine, which means negative divided by negative is positive, right? So there's many checks that you're going through, or I'm going through in my head, to make sure that it works, that my sign is correct, right? They actually said to use the Pythagorean identity to do this. So I didn't even follow the directions. So let me go over here and follow their directions. So here it says sine squared, which would be 3/4 squared. Sorry, I don't know why I'm using this pen, but that's okay. Plus cosine squared, which is going to be my cosine squared. So I'm going to say cosine squared. I don't know what that is, equals to 1. And then I'm going to solve this, right? So solving this would look like this. That would be 9/16 plus cosine squared equals to 1. And then I'd subtract, right? So then I'd get cosine squared equals to, what's 1 minus 9/16? So in my head, I'm thinking 16/16 minus 9/16. You can use a calculator. I'm not going to. So it's 7/16, right? And so if you don't know right now, whenever it says cosine squared, in your brain, you're supposed to know that cosine squared theta is equal to cosine theta squared. Okay. So right now I'm going to take the square root of both sides. Okay. So I'm going to take the square root of this, take the square root of this. Don't forget your plus or minus, right? So then I get left over cosine theta equals to plus or minus the square root of 7 over the square root of 16, which is just 4. And then you say, okay, well, which one would you choose, Miss Johnson, the plus or the minus? Well, according to this, because they told me to use, it's in the second quadrant, that means that my cosine is negative in that quadrant. And I just explained that there. So here, I'm just validating my answer. I would have checked my answers anyway. So here, this is, I think, a way that some of you are really comfortable in, and you can use that way to do this, just to validate your answer. The thing that you cannot forget is this plus or minus business. And this is something that you might have remembered from the quadratic section that you may have had a couple years ago. Whenever you take the square root, you also have to consider the plus or minus, because they're basically asking you in this equation right here, cosine squared theta equals to 7/16. They're saying what number, when I square it, gives me 7/16. And that could be the positive or the negative, right? Because positive, or like if I said x squared equals to, say, I don't know, let's do x squared equals to 9, right? So technically x, a lot of people will say, oh, it's 3, but it's 3 or -3, because -3 quantity squared is 9. -3 times -3 is 9. Okay. So that's part A. Part B says use the quotient identity tangent of theta, sine theta over cosine theta for the given information to find your answer in part A to calculate tan theta. So they're saying, okay, fine. Since tan theta is sine theta over cosine theta, that means that I could put the sine that I have right here. Let me highlight this guy. I could take the sine and put it right here. And I could take the cosine, which I found over here, or right here, and put it down here. So, but it's going to be a fraction. It's going to be a little bit on the messy side, so just stay with me. So it says, let's just put this as 3/4 divided by negative root 7/4. If you remember from your land of fractions, probably in 6th grade, you remember that dividing by a fraction is really just multiplying by the reciprocal. So I'm going to show that here, 3/4 times, and then I'm going to make negative root 7 over 4, his handstand. So it's 4 over negative root 7. And you see, oh, those 4s can divide out. So I'm left with 3 over negative root 7, or whatever, negative root 3 over 7, doesn't matter. Negative 3 over root 7. Sorry, I said that wrong. So then I'm going to highlight this guy here as my answer, right? And I'm going to go back over here to my triangle and check if that's true. So is the tangent, according to what we just found, is the tangent of that angle, is it 3 over negative root 7? And you're like, yeah, opposite is 3. Adjacent is negative root 7. So yeah, that works, Miss Johnson. It's correct. And you're right. So the way that I want you to think about this is, which way do you like better? Because if I just ask you to do something like down here for number 15, you could use the identities, sine squared plus cosine squared equals 1, or tangent equals sine over cosine, or you can use this triangle. This is why this triangle is so darn useful to me. Okay, so if you like using the unit circle, you probably wouldn't have used this. You would probably have to stick to identities. And then I would, again, encourage you to use this as your check. Okay, so thank you so much for listening. Hopefully that makes sense. Again, pick which way makes the most sense to you, and then use the other way to verify and check your answer. Because you do get better at these things as you practice, practice, practice. And so don't think that if this didn't make sense to you that you are lost forever. It just means that you don't get it yet. Thanks for listening.